All right, good morning everybody, and thank you very much for attending our webinar. We're going to be discussing URETEK high-density polyurethane for foundation lifting, soil stabilization for commercial applications. A couple of housekeeping things. During the presentation, everybody's microphone will be muted. If you have questions, there's a question area in the GoToWebinar toolbar. At the end of the presentation, we'll have the Q&A session. So, and if you have questions, please just raise your hand, and we have someone else to get those questions taken care of and put in order. Feel free to chat with anybody else, the option in the GoToWebinar toolbar. And this is for one professional development credit hour. Follow-up email will be sent for this. Again, good morning. My name is Joe Kindler. I'm born and raised in Ohio, graduated from the Ohio State University. I've been working for over 20 years in Ohio as a contractor, material supplier for both the public and private markets. So I've had quite a bit of experience in soils and construction. I've been working with URETEK for over 8 years, and recently, over the past couple, 3 years, we've developed a specification for ODOT that they've been using and have us on state contract. Not a whole lot of applications for that in commercial, but it just lends credibility to our quality of work and our technology and being able to be cost-saving solutions. Now, URETEK Holdings, we are an innovator, industry leader in the geotechnical polymer applications with over 25 years experience and over 85,000 successfully completed projects. We're insured and bonded. We're well experienced with a number of years in those many projects, and we have an excellent safety rating, an EMR of 0.75. We work a lot with the infrastructure, commercial, even residential, and government agencies. We're headquartered down in Lakeland, Florida, and our territory covers 31 states. We have about 30 sales engineers servicing those states. We also have facilities outside of Tampa, one being right here in the Columbus, Ohio area. The technology that we're bringing to the table is for concrete lifting and stabilizing. Again, with over those 25 years of real-world applications, our technology and equipment consistently performs in the harshest conditions and climates. World-class geopolymer material is manufactured by a dedicated chemistry team that produces this material to our specifications and meeting our geotechnical challenges. Again, over 85,000 successful projects. We've completed these worldwide, the most professional experienced crews. So over this 25 years, we've been able to have a lot of experience and be able to gain all that and be able to apply that in all our projects. We customize our monitoring process to ensure that we have good accuracy and verification on every project. So when you're lifting structures, you want to make sure you're lifting what is you're intending on lifting and not lifting what you don't intend to. It's very important to have protocol in monitoring devices to be able to control those. We hold the most patents in this industry. Our advanced injection units consistently perform in the harshest conditions all throughout the United States. Once the material is injected, it reaches approximately 90% strength in about 15 minutes. The other 10% or so comes about in 24 hours. So we're able to turn projects right over to the clients and reduce minimal downtime. Reasons for using URETEK: no dig technology. We're able to make repairs without excavating, without disrupting traffic flows or businesses. We have excellent quality control. Every single project is site specific. It is engineered and catered for that project. No two projects are ever the same. So we have to design these for the injection plan, how the material is going to be applied, take into consideration what the client's expectations are. We're also, again, approved on state contract. Again, it doesn't really apply in the commercial applications, but it just goes to show their credibility and their ability to perform. Chemistry, the material we're using, so keep mentioning the polymer, it's high-density polyurethane. Kind of think of it like great stuff, that foam insulation used on a household, except it'd be like that on steroids. It's a geotechnical polymer. It's a two-part. It only weighs about 4 pounds per cubic foot. So that's free rise, meaning if you're to spray it unconfined, it'd be about 4 pounds per cubic foot. There are about 9 different formulations of material at our disposal to use for different applications of material, whether it be void filling, permeating, lifting, what have you. The material can achieve up to 25 pounds per cubic foot under confinement. On average, the material will expand up to about 15 times its original size. Again, that's free rise under confinement, not quite as much as 15 times, but that's good for void filling and stabilizing structures. Material we use is also hydro-insensitive. That's our buzzword for saying hydrophobic. So the material can be injected into water-laden soils or even standing water. The water will not affect the structure of the material. It will still set up and perform. Our material also meets and exceeds environmental standards. Once the material is set up, there's no more chemical leaching or off-gassing. It can be excavated and disposed of in any landfill or treated however. It is not hazardous whatsoever. The material is also NSF 61 certified. That means it can be used around potable water. The material is a two-part. You have an iso and a resin, or resin and hardener. It's a 1-to-1 mix ratio. When these two liquids come together, you have an exothermic reaction that produces carbon dioxide. It's the release of that energy that creates the soil densification, the void filling, or the lifting of structures. It's that expansion of the material that creates those results. It's relatively fast. You get full expansion in about 30 seconds. So again, with our monitoring systems and the expansion of the material, we're able to control where the material flows and where it's at to stay within the confines of what has been engineered for site projects. Material, because it sets up so quickly, again, you get about 90% strength in 15 minutes. So no sooner than the crews are finished working, you can turn it back over to the client and can be back in service. You're increasing load-bearing capacity of soils, increasing the compressive strength, and not only that, increasing tensile strength. So you can increase the strength, the tensile strength in these soils so that you can span over weak areas. And again, because of the fast reaction time of the material, the spread is limited due to this. Again, about 4 pounds, hydro-insensitive. The reason why it's hydro-insensitive is there's water-insoluble diluents mixed into the material. Not all high-density polyurethanes are hydro-insensitive or hydrophobic. You want to use a material that is hydro-insensitive, because if it's the opposite, being hydrophilic, they can continue to expand past injections. The material is fairly chemically resistant. The only real issue that the high-density polyurethane really has is ultraviolet radiation from the sun. Since we're placing under structures and soils, the sun never really reaches it. So one of the other go-tos used to be cementitious grout for mud jacking, which several people are familiar with. Advantages of using high-density polyurethane: your injection hole. It's 5/8 of an inch, about the size of your thumb, versus 2.5 inches. You have full reaction of the material, setting up, being hydro-insensitive. Standing water, cementitious grout will not set up. Under dynamic loading, laboratory loads, cementitious grout will fill. So if you're injecting underneath a moving piece of equipment or forklift traffic, cementitious grout will break apart. High-density polyurethane will not. You're able to lift within a quarter, possibly 1/8 of an inch using the high-density polyurethane. Also, the material is much lighter than cementitious grout. And once the cementitious grout sets up, it will shrink. There will be some shrinkage due to the water drying out. Also, your cure time, days versus a few minutes. Again, recapping on the advantages: setting up so quickly, 15 minutes, minimal disruption of traffic, able to control the expansion of the material, being able to bring slabs back into alignment, and your weight to ratio far exceeds anything else. And it's also impervious to water and most chemicals. Now, there are a couple different methods and processes for using high-density polyurethane. One is the URETEK method. That is injecting the material directly below the slab. Applications for this might be warehousing, where you have some settlement, you don't have load transfer across those joints in your concrete panels. That's with the assumption that you have solid, strong foundation soils, your subbase is intact. The second process would be the deep injection. That is injecting high-density polyurethane in situ, meaning in place, directly into the weak soils, and that is determined by pre-testing, soil testing to determine where the soils are weak and increase the load-bearing capacity of those soils by deep injecting high-density polyurethane. On the research and development side, the picture on the left shows an asphalt surface on top, then your base materials, then your sub-base. High-density polyurethane was injected into this area. As it permeates through the soils, it will blend with the soils. It will expand in the path of least resistance. It does not displace the soils or aggregates and create a big ball of foam, if you will. It will permeate and blend with those, not only increasing the load-bearing capacity, but also the tensile strength. The picture on the right is another soil box deconstructed where you have soils injected with HDP material. This excavator operator was able to kick or lift this excavator up 11 inches, putting that much load onto the soils without any failure. So it's pretty obvious the amount of strength that HDP material can add to the soils. Here, this project was a test for a firm where, working in sandy soils, they wanted to see how the HDP material would react in these soils, in these sandy soils. So this slab was placed out there, and the goal was to stabilize the slab so that the rest of the soils could be excavated around, and the slab would remain stationary. Here you can see some tubes that are existing after injection. And it's pretty amazing the things that you can do with this high-density polyurethane. We were able to inject around the perimeter of this slab, creating a grout curtain wall, if you will. So then when we went through the slab in the center and injected, the material had confinement, because remember, as I mentioned earlier, HDP will expand in the path of least resistance. We ultimately want to have it up against this slab stabilizing. So because we created this grout curtain wall, we have confinement of the material on the interior soils so that it densifies by you consuming the least amount of materials. So you can see the excavation and how the material blended with the soils. It didn't displace them and create these big balls of foam like I mentioned earlier. It actually blends with the soils. You can see a little bit of a fissure here where the soils with HDP material was able to travel. Another example of injecting high-density polyurethane into soils. Here, the materials, this HDP material was injected into these soils. They were excavated out and pulled out for examination. Now, one of the things I like to bring up on this is questions that often comes up. How difficult would it be to dig through this material? How dense is it? Is it like concrete? Think of it kind of like LSM, a low-strength mortar. It is diggable through mechanical devices. I would not want to take a shovel to it, but if this operator wanted to, they could break this apart and dismantle it. And again, if it was post-construction and they wanted to dispose of it, it could be easily disposed of. There's no environmental impact. Injecting into peat or organic soils, those are a big issue. Pretty much every county throughout Ohio has a peat problem somewhere, someplace. The problem with peat is they have a 60% void that's filled with water. It's constantly decomposing. So we see a lot of settlement. I see a lot of facilities where they have settlement in their warehousing, their factories, what have you. The HDP material can be injected in such a way where it creates a honeycomb effect to help stabilize or support a rigid structure above. Here, this overhead view, you can see the honeycomb structure where the HDP material was injected into the soils and created this structure. Here, the goal was not to fill the soils up 100% because of consumption of material, but strategically inject the material to be able to achieve the goal of supporting a rigid structure above. The services and applications. In civil works, working with dams, spillways, rehabilitation, stabilizing and sealing. Anytime you have water flowing through a structure, water will eventually erode when find its path of least resistance other than through what we've engineered. It's an application for using HDP material. Seawall erosion and seepage. Okay, we're in Ohio. I know we don't have seas, but we have lakes, we have rivers, so we have all those structures that are up against there to where we have voids, loss of soils, or loss of supportive soils, where we can use the high-density polyurethane to be able to stabilize those. Conduit and outfall rehabilitation, again, recommissioning. So where you have the outfall, we can stabilize and seal those up as well. Infrastructure, specifically underground infrastructure, manhole rehabilitation and sealing, not just on streets, but also in private facilities where you have catch basins, storm drains, what have you. We get settlement because of water infiltrating or coming through cracks outside the system and robbing those support soils. We can stabilize those, joint seal those storm drain lines that have become askew or separated, so you have solids coming in from around the pipe, coming into there, causing voids. We can stabilize those all in place. Sealing up the culverts and realigning any structural and lifting them back to grade. Foundation lifting and stabilizing, again an illustration of a rigid pavement slab, void filling, stabilizing, bringing them back up. Big point I want to make here is a lot of the testing has shown, and this right here, this joint, once you have stabilized and void filled, you now have excellent load transfer. So in warehousing, manufacturing, what have you, where you have forklifts running back and forth, you now have an excellent load transfer from this panel to this panel by using the high-density polyurethane. And under vibratory loads, constant impact of traffic, the high-density polyurethane will stay intact. All right, let's get to the good stuff. Project examples. Where has it been done? Talk about rehabilitation. Here I had a project down in Cincinnati where a commercial slab lift. The slabs had wound up settling, causing deflection in the ceilings, as you can see above, cracking windows, binding doors, and creating trip hazards. So high-density polyurethane was injected underneath the slabs, expanding, wall monitoring, and bringing those slabs back up to grade, eliminating the trip hazards, and bringing the structures back into alignment. The nice thing is this was done all within a day with no disruption to the business. Again, holes are only about 5/8 of an inch, so they're able to work with the carpet, just cutting small flap through, drilling, vacuuming, cleaning everything up, and all those holes are grouted closed and the carpet replaced. Down in Jacksonville, Florida, Costco, an issue here. They have post-construction settlement. The reason they had this post-construction settlement is there were buried debris, organic materials, trees, what have you. As those decompose, they break down, then you have settlement. They were having circular cracking areas on their concrete floors and settlement. So URETEK was commissioned to come in and did some GPR, ground penetrating radar, to determine where those voids were and to the extent of them as far as the surface area. An injection plan was put together. Here you can see the tubes that are being put in place, because it was determined that the soils were weak at the -8 and 16 foot mark. So materials were injected. Here the injection process is going on, and again, laser measurements can determine if there's even a millimeter of movement. So that's the kind of controls that are placed on this. So the materials injected, soils were stabilized, able to work at night when the customers weren't there, so Costco did not experience any downtime with this. And as no sooner we're finished, we're able to open it right back up to them. Down in over in New Jersey, rather, hospital tunnel. What they had is a pedestrian tunnel going between the two buildings. At one of the joint, they had groundwater coming in, seeping in through there. Again, able to work with this in one day, injecting the high-density polyurethane. You can see some of it outcropping through the joint. It's placed in the soils, then coming back through there and sealing this up, preventing any more intrusion of water into there. Again, a nice thing is being able to work with this, with the high-density polyurethane. You can work on a project, pull off, and then pick right back up where you were and continue injecting. So this comes about for large projects where it may take several days to do or several weeks, or because of budgetary concerns. You can work on one part of an area because of working within a budget, and then add to it the following quarter, year, whatever. Down in Florida, Marriott's Orlando World Center pool, they detected voids under there. So they had to dewater the pool. Again, GPR was brought in, ground penetrating radar, to identify where these voids were. And HDP material was injected. Again, monitoring, making sure do not cause any undue stress to the pool, and injecting the material. Complete this all within a day. Kent State University here in Ohio, they have a dam for one of their wetland areas. The problem that they're having is the water was undercutting the inlet slab. So water was traveling underneath the dam and bypassing the dam itself and causing erosion and settlement. So HDP material was injected into these soils, filling in any voids that are underneath here, and densifying those soils, creating a grout curtain wall, if you will, forcing the water to flow over the dam. Again, it's important to have a material that is hydro-insensitive because we were injecting right into the water. Any excess material was contained within the booms, so nothing went into the environment, and it's completed in 1 day. Down in Greer, South Carolina, BMW factory, they wanted to add an additional penthouse, a second story. Engineering firm, I believe it was Stantec or SME they were working with, was looking over the plans, and they determined, well, they need to increase the load-bearing capacity of the soils underneath the columns here. So URETEK was commissioned again, and SME did the pre and post testing to verify densification of those soils. Here you can see the injection tubes where the HDP material was injected in situ, stabilizing those soils, and then SME was able to go back and do post verification of increasing load-bearing capacity. So we're able to well exceed their expectations on what they wanted. The material itself is about 8,000 pounds per square foot, so greatly exceeded their specifications on that. Minneapolis and manufacturing facility. Here they had some settlement of a slab up to 8 inches. These slabs were down. They had some weak soils down there, and they're able to inject the high-density polyurethane, and it lends some credits to how strong, how much force this HDP material can direct towards these slabs and bring them back up. Able to complete it within 4 days. Again, no disruption to the client, able to work around their schedule whenever they were shut down, able to work in there. Again, being able to bring that back up than 8 inches. The Ohio State University had a bus loop on one of their parking lots. They have here are 9-inch thick concrete panels, and they were all stair-stepped, if you will. All of them had some settlement, and the rideability was quite poor, and the pads were starting to fracture and break, have mid-panel breaks. So here illustrating doing some soil testing prior, find out the soil strengths, doing dynamic cone petrometer testing, verify that, and that helped design the injection pattern of the HDP material. You can see how all the injection ports on those panels and injecting the HDP material while monitoring it and bringing them back up to grade. There were previous repair attempts made. They used cementitious grout to mud jack and bring it back up. However, that was short-lived. As I mentioned before, under vibratory loads, cementitious grout will fail and break apart, as the case is here. So able to bring this back up over 3 days, did a significant part of it, and hence also having that excellent load transfer from the panel to panel. So this is where the buses run constantly. So we're able to bring that back up and have a successful repair for them. All right, repurposing and recommissioning. We're in Tulsa, Oklahoma. They have here is a steel facility, which the building was originally designed for a different type of industry. The essence of it is the concrete wasn't designed to hold equipment that holds 50,000 pound steel coils. So they started seeing some settlement of the pads and movement of the equipment. So URETEK was commissioned to do the project, doing both method, sealing up the voids, stabilizing the slabs and lifting the slabs back to grade, and also deep injection, increasing the load-bearing capacity of those soils to be able to withstand the enormous weights. So they're able to bring this slab back up to grade, which is a little over an inch, and they're able to complete this during their plant shutdown and very little disruption to the client as well in a short period of time. Newport shipyard, they had an issue here. They have a 150 ton crane that was starting to settle. So they had to keep shimming the crane because the wooden piles are starting to settle. Here they did some excavation to determine what might be causing it, and came back and we did some DCP testing and injected the high density polyurethane. Now, one of the things that's interesting on this project, again, kind of like this sandy soil concrete slab slide I showed earlier, in order to really densify those soils around those wooden piles, they created a perimeter of injections of HDP to create a grout curtain wall again, and then injected on the interior so the material can push off itself, densifying, squeezing, if you will, those piles. Not only were they able to stabilize, but they were able to create some lift on that. And they did this without weight and then with 150 ton on the crane. They're able to stabilize this, and they did the DCP testing pre and post for verification on that. Up in Michigan, tank stabilization. What they had here is a 5-foot thick concrete slab. The original design was to support a 40,000 gallon vertical milk tower. At some point they decided to turn this to double it to 80,000 gallons. Engineering firm that was working with them said that shouldn't be a problem. The concrete can support it, however your soils cannot. You have to increase the load bearing capacity of those soils. They didn't have any other options or anything that worked within their timeline because this was holding up the renovation. So they commissioned URETEK to come in, did some soil testing, and determined an injection pattern of -8 feet, 12 feet, and 16 feet. So subcontractor was pulled in to drill through that 5 feet of concrete, which that took actually longer than the whole injection process. The material was injected, verified, increased the load bearing capacity of the soils, and they were able to continue work half an hour after we pulled off. So they had that 90% strength within 15 minutes. So it did not halt their schedule for putting that tank on. Unfortunately, it was so successful on their next one, they called us in to increase the load bearing capacity of the soils on the next pad, which you can see is this one, and they were kind enough to put a porthole so we didn't have to drill through 5 feet of concrete. So sometimes when they're designing these things, any access provided to us is very helpful. We're able to stabilize that as well, and without any disruption to their production schedule. University of Tennessee had a pre-existing historical build factory warehouse where they were going to renovate and rebuild. However, through their studies, the geotechnical studies, they found that the soils were weak, supporting the columns. They looked at several options, and they decided to use the URETEK deep injection process. Because we're able to perform the work in just 6 weeks versus other repair methods, and we're 60% of the cost of other repair methods considered. So they had engineering firm perform pre and post inspection to verify increasing load bearing capacity of the soils, and we're able to inject and stabilize and come up to their specifications for the densification of the soils. Another project, underground infrastructure, back in Cincinnati, Ohio. ODOT had an issue. Their issue is they have this 11-foot CMP corrugated metal pipe that's 532 feet long. It runs under I-275 just east of I-75. The invert, the bottom of the CMP, had rusted out. And as there are 3 creeks that converge coming this way, and this way. As those creeks would flow through this compromised CMP, it would rob the support soils. When it come up and fill up, it would saturate the soils on either side. And then ultimately, as the water would drain out and go out, it would rob those support soils. It was so bad that it caused a deflection on the pavement system up above, 50 feet above, at full depth asphalt. And it's across 6 lanes, and it was deflected anywhere from 2 to 6 inches. So one part of it was to inject underneath the pavement system and then bring the pavement back up to grade, which was done over 3 nights. And the second part was to fill in these voids, the suspected voids on either side of the CMP. Now, the pipe was relined with concrete, so the water would no longer go outside the pipe. They knew they had the voids, so HDP material was injected into those voided areas. Again, important to use a material that is hydro-insensitive or hydrophobic if you're injecting into water-laden soils. The challenge that we had is the material was coming out the other end of the pipe and had not set up yet. So this material was traveling 532 feet in less than half a minute. What we discovered was the fact that so much water was flowing underneath this slab and taking it. So we had to work with a project engineer, call an audible on this project, and inject it into the support soils into the creek bed. There was no strength in there. Once the material was expanding, it was forcing the water to flow back up into the pipe instead of under it. The thing that was so interesting is you start having material coming up out of the creek bed 15 feet upstream. So then that was completed. Once those soils were densified, then injections were continued along the pipe and filling in those voids. Again, 2-day, and their only other option really was to rip everything out, which would be in the millions of dollars. So I'm going to go ahead and take some questions now. Please keep in mind we do have another webinar coming up September 16th. It's inside outside infrastructure. So relining the pipes and also stabilizing the soils. First question I have, what is the expected lifespan of the polymer being used? Excellent question. And the honest answer, nobody really knows for sure. We see up to 20 years. Reason being, because we've been doing it for 25 years. Material has been pulled out of the ground. We had one at Lackland Air Force Base that had been in the ground for 10 years. It was just as good as the day it went in. The manufacturer gives a warranty of 10 years. The manufacturer of the material. As I mentioned, the only real issue that it has is ultraviolet radiation, so it's not reaching the ground. So you'd expect easily 20 years life experience out of that. Let's see here, looking to see if we have another question. Okay. How does the material respond to high groundwater? Okay. You're still going to have the groundwater there. What we can do is influence the groundwater or push it or redirect it in another area, if you will. So if you're working with a, say, we had one, for example, working with the city of Akron where they had a parking garage where they had high water table and water was coming in through the garage. What we were able to do is come up with an injection plan to stabilize and seal up most of it, but we still had to allow for the water to come through someplace. So they were going to build a drain for the water to be able to seep out and come out. Because the material, as it expands, it will displace water because it's expanding the path of least resistance, so it will push, squeeze, what have you. So we have to be very cognizant of the fact. That's why we want as much soil data as possible. If we're working, let's say, in a factory and you have some high water table, generally we like to start in the center and work our way out as to push the water out of the soils from where we're injecting. I hope I've answered your question. And I think we have a third question coming up. In the 5-foot thick slabs, could you use the product to fill the access holes, or did they fill them with concrete? Another good question. Now, used a cementitious grout or a mortar. I'm sorry, not cementitious grout. Used a mortar, a cementitious material to fill in those holes. We can use that. We can use polymer materials. We don't like to fill it in with HDP material. We want something of cementitious material or patching material. But whatever we have, sometimes we have clients that want a specific material used for that, and we'll work with that, whatever they need. Fourth question, how is a slab being lifted, weighted down to prevent overlifted? I like that question because I get asked that. Another way I've heard it is, what do you do if you overlift something? You apologize and hope you still get paid. Now, not being facetious, being serious, would use to, that's why we monitor. We know if we're lifting something a millimeter so that we have controls, we don't overlift something. Now we would use, and I think another part of the question was weighting down something, holding something down. We've done that before where we're trying, you have a bit of a bind between two slabs. One you don't want lifted, the other you do. So the one that you don't want lifted, yes, you can weigh it down, put weights on it, whether it be equipment, what have you, to help prevent that slab from coming up. Sometimes we do put weights. For example, that Tennessee project, they wanted to make sure they had good densification, so they put weights on top of where they're injecting so that it would create more confinement, make the material denser, so you'd have even increased load-bearing capacity in there. Okay, another question. Is there a maximum depth pressure for injection? Yes, there is a maximum depth. Again, we have about 9 different formulations of material. They do different things. They react differently. Typically, material can be injected up to about 50 feet, down to 50 feet. That can be adjusted somewhat. And the reason for that is because of the reaction time of the material. We have to get it through the tube, if you will, before it sets up within that 30-second period of time. Okay, how does the material respond through ground freeze and thaw cycles? You're still going to have your freeze and thaw. So if you have any moisture in there, you're still going to have some heaving. The nice thing about the HDP material is it'll displace any pockets where water would be, so you'll have less freeze and thaw, or expansion and contraction due to freeze and thaw cycles. One of the things to keep in mind is we do not want to inject when the ground is frozen. Reason being, if you have trapped water there, you're going to have a false void. So you're bringing that into the equation when you lift, and then once that water thaws out, you're going to have some post-injection settlement. So typically, segueing into another question, usually falls up. Usually working in environments is about 40 degrees on up. Yes, we can make provisions to work in freezing temperatures if need be. Okay, another question. What soil types are optimal for the materials to densify? What soils are not? I would say sandy soils are all, probably the best, the ultimate. Reason being, typically, 2 reasons. One, the material permeates very well through sandy soils. You also have a lower void content, so it'll consume less material. Whenever we run across large voids, we will wind up having them filled in with sand versus like a 57 stone or a pea gravel or anything of that nature, just because it's more flowable. You can blow it in. It can be dirty, wet, clean, dry, doesn't matter. Just get the sand in there. and you'll have a lower void content. Typically, when the material is injected into clays, depending on how dense they are, the material generally will travel laterally until it finds a path of least resistance. Again, very important to have soil data. If you have an expanding, contracting clays, those can be challenging because, yes, we can create lift, but you're still going to have the expansion and contraction of those clays unless you have them dewatered in some way. So alleviating any downspouts, broken pipes, groundwater, what have you, springs, to prevent that from happening. Organic soils, those are optimum. Those are fantastic. However, they can be expensive because you have a 60% void and can consume a lot of material. I believe we have another question coming up. Has the material been utilized to form subsurface column type supports, meaning only grout? Meaning only grout columns. So in other words, I need a little more clarification on that question. I want to make sure I answered appropriately. And I'm thinking, is a question being used, is the material been used to create piering, possible piering columns, like grout columns? I'll go ahead and answer it that way. Yes, the material, the nice thing is how the material reacts, we can come up with an injection pattern to create piering effects. In other words, when we place those tubes down through the soils, we're disturbing those soils, and we can do it in such a way that the material, it will follow the path of least resistance, which will be through those tubes, and we can create a piering type effect with the HDP material. So yes, we can have columns. We have had successful projects where we've created, I give you a visual, creating a grout curtain wall, if you will, by having a series of these tubes to create confinement supporting soils for excavation. And what you'll see is a very nice cylindrical, up to about a 6-inch pier of HDP material, or soils impregnated with HDP material. How long does it take for the material to set? You get full expansion in about 30 seconds and about 90% strength in 15 minutes. The other 10% or so comes about in 24 hours. So the answer to that question, how long does it take to set? 15 minutes. So we'll work on whether it be pavement systems, warehouses, underground infrastructures, dams, levees, what have you. After 15 minutes, you can turn it loose to traffic. All right, and I think that's all the questions for now. If anybody has anything else, we've got a couple minutes left here. Just a couple notes here. Please connect with us on Facebook, Twitter, LinkedIn. We're very involved in social media. Please like us on there. Greatly appreciate it. A lot of good stuff, information on there. It's one of our priorities, and any likes on that would be greatly appreciated. Other than that, if aren't any other questions, I greatly appreciate everybody's time. I hope you found it informative. I'm always available. If anybody has any further questions, please reach out to us. We'll get them answered. We'll have an email out to you with your professional development credit hour certificate. Again, thank you everybody for spending the time with us.